metals in the water. Doesn't matter what brand you're using, whatever it may be, a polyphosphate is designed to sequester those metals. Okay, so the metals that are coming out of your tap are going to be are going to come out of your tap, whether it's iron or manganese or total hardness.
All right. The RO filter actually filters particles to the size of 0.001 MC in size or smaller. All right? Right. So to plug up these filters, how big might these particles be?
Well, so let me ask you a question. If an iron particle that's coming off of a pipe is 3 microns, or if it's 0.03 microns, what difference does that make?
Well, the difference it makes is that the difference in the concern that we have is that these phosphates are by the ionization process. It is encapsulating these small particles of metals, and they're traveling through the pipe, and we can't filter them out. So we're getting some. That's our health concern. It's not phosphates in general. We understand all those studies about phosphates in general. Yeah.
So let me tell you what the number is, okay? Our treatment rate is designed so that there will never be a release of more than a 0.15 parts per million or milligrams per liter of any type of divalent metal getting into the tap, okay? It'll never be higher than that number. And that's because that's the way the treatment rate is designed. Now, in most cases, in almost every case, it's never going to be that high. And the reason is because what we're doing is that 0.15 milligrams per liter is also coating the metal, and it's doing a lot of stuff in the system. But you'll never have a higher ratio than that. If you want to go down to Whole Foods right now, you can pick up a iron tablet, if you have an iron deficiency, for 150 milligrams per liter. Okay, so that's 1,000 times more than a 0.15. So what I'm saying is that that the amount that's being released into the system is clearly 100%. In no way affects water quality or human health whatsoever. Okay. You need to have iron in your system, and it's a nutrient, and as is calcium hardness. So these are things that, and you don't even have that much metals in your system altogether. You're treating at a 0.5 part per million, which is our lowest ratio. You don't have a lot of stuff in your system. So you're not talking about anything that's going to be in huge quantities. If you want huge quantities, go to the health food store and you can get the tablets.
Okay. So I don't think we have an iron problem. It's mainly copper in the houses. And that was going to be my question to you. Does it make a difference when these chemicals run through PVC and then hit the copper of dwellings, which is basically what we're looking at here? I mean, it doesn't have that chance to actually contact anything in its travels until it gets to your house.
Yeah.
So how would that affect the effectiveness of this product?
Well, your copper fittings are in the house. They're not in distribution. That's number one. Mm-hmm. Number two, that we're coating the copper to prevent and stop erosion of the copper. Mm-hmm. So that what we're doing is we're preventing copper from coming into your system and leaching out into your tap. I mean, that's the whole point of the lead and copper rule, is to test for that to make sure that you're within compliance of U.S. EPA standards.
Yep.
So you're not getting any type of copper leaching into your system when you use the Sequest.
Mm-hmm. And another, just on a side note.
Sure.
We have testing that's done on our water, but if the particles are less than 1/2 of a micron, they might only be indicating phosphates and not the metals that are bound up in these phosphates. Also, as our district pipes are PVC, the OPP has nothing to work on until it reaches that. Was another one of my concerns is what does it do if it hits the load that hits our house and our faucets without actually working along the way? And so we have a lot of questions about that. And it's been like described to us that the phosphate, which is ionized, okay, so now it has a charge, is the grabbing component. Okay, it grabs the metals, all right? But then it had another component that was described as a chemical component to the person who was on the phone, and it had the function of grinding those particles down to a smaller size. And I'd like to know what that chemical component is. Can you release that information?
Well, the chemical component of what? Of the sequence?
Of the grinding, the part that has the function of grinding those particles down to a smaller size. Would that be a silica particle?
Okay, grinding is a terrible word. It's not a grinding.
But that's exactly how it was described on the phone.
Okay, so I'm sorry, I didn't write the article, and you know what? And I apologize. I mean, look, grinding or dispersion. I guess we could use the same terminology, but what it's doing is it's just making a large particle smaller. That's all it's doing. But it's not a magical formulation where it's turning one thing into another, okay? Polyphosphates sequester divalent metals, all right? And that's what we're doing. Now, when it's an iron 3 as opposed to an iron 2, you can't sequester that. It's impossible. You cannot sequester rust, okay? The only thing you can do with it is disperse it so when it comes out of the tap, it's not going to look red, and you're not going to have red water. And so what we do is we disperse. Part of the technology of Sequest is it's taking whatever iron or manganese or total hardness you have. If it's in a state, of a 3, a +3 instead of a +2, and what it's going to do is it's just going to disperse it. So, but it's still there, and it's and that's what it is. I mean, that'll happen with any product, except a lot of times with other products, you're going to see red water, or you're going to see black water, because it's not going to be able to disperse it correctly. We are the most powerful sequestrant on the market.
Right, I understand that. Yeah, it's a good product. It does what it's supposed to do.
And also, I just want to let you know, not only is it not giving you any additional metals that you're already getting out of the tap, but it's also reducing the amount of other chemicals that you're using. I mean, if anything, this should be like a phenomenal, it is a phenomenal technology, and we're the only technology that's been written about at the AWWA Water Quality Technology Conference. We've had 2 papers presented on our technology from independent people, and we had a front page article on our technology in OpFlow, which is I guess the Bible magazine of our industry. And, so it's a pretty unique and a pretty exciting technology in terms of what it does.
Yeah,
anything that's going to help reduce your usage of other chemicals has to be a good thing for the system.
Okay. We just got one more question. Okay.
Sure.
It is about the sequestrian. Sequestered and more of the hydrogen bonding precursors they've developed. I'm reading from a paper here.
Yeah, okay.
The overall integrity of the deposit mass changes its color chemistry and becomes softened. I think it's talking about iron and not copper. Once softened enough, this mass can be flushed out by hydrant flushing or simply disappears in the normal course of flow without any negative effects to water. How does it just disappear?
Okay, so that's the dispersion process.
So where does it go?
Well, it goes out of the tap, like I just described before. It disappears. It's right there in the tap. If you see an iron, if you test it for iron at the tap, your iron number is going to be the same. The only difference is it's not going to be red. It's going to be crystal clear.
So it's still there?
It's still, yeah, absolutely. We don't make it disappear in terms of taking it away. It's still there. We just make it disappear visually because we're reducing the size of the molecule, to something through dispersion or grinding, down to something that's literally submicronic. So
thank you very much for your information, sir.
To clarify, you're talking about rust and iron, right?
Correct. That's
Which
correct.
is not an issue with you.